Hi, my name is Sam Rapoport, and today I'm going to be talking about how robotic craft inform us about Mars. The probes and rovers we send to Mars have been a major tool in gathering information about the planet. And, as we have seen, this information has transformed Mars in popular culture from a dead canal filled world to the first major step of human space exploration. This brings up the question, why use robots and not humans? In Dr. Daniel Britt's words, humans are heavy, fragile, dirty, and vulnerable. Robots are just a more logical and cheaper first step. You don't need to transport heavy food or water, or worry about a return trip, and robots are self-sufficient and won't die from extended radiation. The next question is then, why have humans at all? Stephen Hawking argues that humanity's long-term goal is to colonize other planets to ensure our species' survival. But if we're looking practically at the near future, humans are much more equipped to deal with unexpected situations than robots, and are necessary for more long-term complex tasks, such as field studies. So let's not put the cart before the horse, or the human before the robot. Robots are fantastic for gathering data about Mars and the many details we'll need to streamline the path for safe human exploration. So now that we've decided that robots are the better starting point to learn about Mars, how do we go about using them? NASA has developed a fairly comprehensive but simple plan for it. I'm just going to give you a fair warning. This is about to get pretty US-centric. That's because pretty much every mission recently, minus ExoMars, has been done by NASA. The other exception to this is the Mars Orbiter mission by India's space program, which was mainly just a test run. So that's why I'll be focusing on NASA's goals for Mars. Here are NASA's 4 science goals for the Mars exploration program. 1. To determine whether life ever arose on Mars by looking for organic compounds and water. 2. Characterize the climate of Mars. 3. Characterize the geology to give more insight into Mars's and Earth's past. And 4. To prepare for human space exploration. The first strategy NASA used to accomplish these goals is to find out more about the distribution of water on Mars, because life as we know it needs water to develop. The next and current strategies that we are in is to learn how habitable Mars was in the past and seeking signs of life, to see if it ever occurred on the planet. The final and most broad strategy is to prepare for human space exploration. Now, let's get to the good stuff and talk about some actual robots we sent. The Mars Reconnaissance Orbiter landed in 2006, and its main objective fell under the follow the water strategy, to study the history of water on Mars and observe where past oceans were located. In addition, it monitored the Martian weather and gave detailed views of the surface. The next probe was the Phoenix lander in 2008. Continuing with the follow the water strategy, Phoenix studied the ice and soil in Martian Arctic to unveil more about the history of water on the planet, showing that Mars used to be better and warmer, but no traces of life are discovered. 6 months later, the lander died a cold but expected death. Now, onto the big man himself. Curiosity, or the Mars Science Laboratory if you don't like fun, landed in 2012, and his main job is to travel the planet and take soil and rock samples to learn more about Mars's past geology and habitability. Curiosity also proves the feasibility of using a sky crane for landing. Next up is MAVEN, or the Mars Atmosphere and Volatile Evolution mission, which arrived in Mars in 2013. MAVEN's mission is to take detailed samples of the upper atmosphere and gas emission rates to give a better picture of how Mars's atmosphere has changed over time and what role the sun has played in altering it. And dealing a solid blow to American exceptionalism, the ESA has just launched ExoMars 2016, which includes a satellite and lander. The satellite, called the Trace Gas Orbiter, will scour the atmosphere for gases relevant to life such as methane. Meanwhile, the lander, named Schiaparelli, will provide critical information about Martian entry conditions, paving the way for more reliable and accurate future landings. ExoMars 2018, the second part of the mission, will put an ESA rover and Russian surface platform on Mars. The rover will be equipped with a 2-meter-long drill to search for preserved signs of life deep beneath the Martian surface. It will communicate with Earth via the Trace Gas Orbiter, while the Russian platform will take an extended observation of the Martian climate over a full year. Back in the States, NASA has delayed the launch of the wonderfully named InSight lander until 2020. InSight's mission is to learn more about the interior of Mars using a 5-meter-long heat probe, giving better insight into how terrestrial planets like Earth were formed, more specifically the currently poorly understood creation process of core, mantle, and crust. The Mars 2020 rover is the last robot in development, and is shockingly set for launch in 2020. It will use the same basic design as Curiosity, and will gather more information about Martian geology and weather, collecting rock samples that can be returned to Earth, and will be equipped with instruments to test oxygen extraction from atmospheric CO2. So you may be saying to yourself, old rocks and science are all fine and dandy, but how's this information useful to us? Well, thanks to robots, future landings will be more accurate and safer, and we'll be able to eliminate problems arising from Mars' unfamiliar atmosphere and chemistry before a single astronaut has to experience them firsthand. Speaking of astronauts, within a decade or two, we're going to find it necessary to have both humans and robots on Mars for more extensive and varied tasks, such as field studies and construction. Robots can shoulder the dangerous, labor-intensive, monotonous work, while humans can fix unexpected problems that arise and manage evolving projects. Numerous sci-fi authors have already speculated how this would work, such as Isaac Asimov and Kim Stanley Robinson. Asimov's iRobot follows two scientists whose job are to work out the kinks of new robots when they inevitably start acting up, showing the necessity of on-site human supervisors. No matter how well-tested new technology is, problems will arise and humans will need to be around to fix them. The early part of Kim Stanley Robinson's Red Mars shows a realistic view of how humans and robots would work together on Mars. Programmable rovers and machines would be able to do manual labor such as digging and construction, and humans would be on site to oversee the robots' work initially, and then would be free to focus on research and managing other evolving projects. In conclusion, robots are a fantastic tool for learning about everything Mars: atmosphere, geology, chemistry, weather. Robots have allowed us to gain invaluable knowledge of the planet at a fairly low cost and no risk to human life. But as our planet's plans for Mars get more ambitious and humans enter the picture, we will need to expand and adapt our use of robots to make space exploration cheaper, safer, and faster for all of humanity. Thank you.